So our learning target, I can use the dilution formula to determine how to make more dilute solutions. So for example, when I buy acid, I have to buy concentrated solutions of acid, and then I take that acid and I combine it with water to get more dilute solutions that I let you guys use. So I have to calculate how much of that strong acid to use to create those dilute solutions. So our formula is M1V1 equals M2V2. Okay, so that's in your reference packet on page 3. So the big key here is to keep the molarity and volume together. That's supposed to go together. So if we look at our example, remember you have these, it says how many milliliters, okay, so that's what we're trying to find a volume of 6 molar HCl, so that's a molarity, is required to make 500 milliliters of 1 molar HCl. Alright, so I need to keep the 500 milliliters and the 1 molar together because that's what I'm trying to make. I'm trying to make 500 milliliters of 1 molar HCl. So I'm going to call those my 1s. So I'm going to call these my 2s. It doesn't really matter which designation you give them, as long as the 6 molar is with my unknown. So then I plug this into my formula, so I get 1 times 500 equals 6 times x. Okay, and then I'm going to solve for x by dividing both sides by 6. And so my answer, oh, I thought I had it on the page here. Okay, found it. The answer is 83.3 milliliters of 6 molar hydrochloric acid is going to be required to make this solution. Our next example, we have 614 milliliters added to 50 milliliters of 1.3 molar solution of NaOH. What is the new molarity? Alright, so I'm trying to find a molarity. Now, I've got a couple of different volumes here, but we have to pay attention. Now, 50 milliliters of 1.3 molar solution, those have to go together. So I'm going to call those my 1s. Now here, it says 614 milliliters is added to 50 milliliters. So what we have to do to get our V2 is do 614 plus 50. So that's going to give me a total volume of 664 milliliters. Okay, so we're going to call those our 2s. So we have to use the total volume, remember, for molarity. So now we can plug our numbers in. M1 is 1.3 molar. Okay, V1 is 50 milliliters. Alright, M2 is what we're trying to find, so that's going to be X. Now our V2, remember, is we've added these up, so we get 664 milliliters. So now we're going to solve for X, so remember that you're going to divide both sides, and that will cancel, and your answer is going to be 0.098 molar sodium hydroxide.